Hello and welcome to EduSathi's lecture on logarithms and exponentials. Let us first define what is an exponential function. An exponential function defined as fx equals to a raised to power x, where the quantity a is defined as the base and is constant. Also, the base has to be greater than 0 but not equal to 1. So, the base that you are taking a in an exponential function has to be always positive and would never be equal to 1, because 1 raised to power anything will end up in 1. So, the thing which is very important is, first of all, it has to be greater than 0, and second, it has not to be equal to 1. So, an exponential function fx would be written as a raised to power x. And if I want to take an example, I can take it as 5 raised to power x. Fx is equal to 5 raised to power x, or y is equal to 5 raised to power x. Now, here x will be an independent function or an independent variable, also known as the input, and y will be a dependent variable, also known as the output. So, if I move further and look at the graph for an exponential function, the graph would depend upon the value of the base. If the base is between 0 and 1, it will be a different graph that I will end up with. If the base is greater than 1, the graph will be a different one. So, it will not be the same graph, because if you look at it, if you take a number which is less than 1, for example 0.5 raised to power x, as the x increases, the final output will tend to fall. And here, if you have 5 raised to power x, if your x increases, the output will also increase. Here it is kind of directly proportional, and here it is kind of inversely proportional. So, if I just look at the graph that I get, so as and when your x increases, the value of output would fall. And for a greater than 1, the graph looks something like this. As your x increases, the value goes up, and it's an exponential graph or exponential increase or decrease that happens. Let's look at a question which we have. Which of the x and y is greater, given that ax is greater than ay? So, what I'm given is ax is greater than ay. You have to tell me out of x and y which is greater. Now, just by looking at the question, I cannot say here that x will be greater than y, because I don't know what is the value of the base. If the base is positive, very obvious that x will be greater than y. But if the base is if the base is greater than 1, x would be greater than y. And if the base is between 0 and 1, y would be greater than x. So, is x greater than y or y greater than x? That will depend upon the value of the base. So, if I know the value of the base, I can make a judgment here. In this question, a is not known to me, so I will make two separate cases. When a is greater than this, then x would be greater than y, and when a is between 1 and 0, my other value, which will be y, will be greater than x. So, if a raised to power x is equal to b raised to power x, if powers are same, bases has to be same. A is equal to b. Or if I write, if a raised to power x is equal to a raised to power y, that means what? X will be equal to y. So, if the bases are same, powers can be compared. If the powers are same, bases can be compared. Let's look at some of the properties for exponentials. The first property that we have is a raised to power x into a raised to power y would be written as a raised to power x plus y. This means if bases are same, powers can be clubbed. And if I have a into b raised to power x, this power is for this a also and this power is for this b as well. So it will be a raised to power x into b raised to power x. The second is a raised to power minus x could be written as 1 over a raised to power x. So that means if I take a reciprocal, the power changes its sign. Negative will become positive. Third, a raised to power x over a raised to power y. Again, I could write it as a raised to power x into a raised to power minus y. When the bases are same, powers can be added or subtracted. So I'll get my answer as a raised to power x minus y. Fourth one being a raised to power 0 is equal to 1. Anything raised to power 0 is always 1. I cannot take my base as 0, as I've already told you. The base has to be positive. The base cannot be equal to 1. These are the two conditions that I will always keep in mind. So 0 raised to power x, this is undefined thing that you have. If you have a raised to power x y, so whenever you have this thing, the powers are multiplied to give you a raised to power x into y. So if you have a square and cube of this, it is actually equal to a raised to power 6. But if you have a raised to power x raised to power y, now this y is not associated with this a. This y is the power of this x. So this value a raised to power 2 cube will not be equal to a raised to power 6. This will be equal to a raised to power 2 cube 8. So a raised to power 6 and a raised to power 8 are not equal. So a raised to power x raised to power y is not equal to a raised to power x into y. Now if a raised to power x is equal to b raised to power x, so if the powers are same, bases can be compared. That means a is equal to b, provided the power is not 0. If a raised to power x is equal to a raised to power y, so what is it? If the bases are same, powers can be compared. That means x is equal to y, provided a has to be positive. A should not be equal to 1 because 1 raised to power anything would come out to be same. And a is not equal to 0. That is obviously the case because a has to be positive. The next one is if a raised to power x is greater than b raised to power x, then a is greater than b is greater than 1 when x is positive. So if this is the condition, then what does that mean? If x is positive, if the power is positive, then a is greater than b. If a raised to power x is greater than a raised to power y, then x will be greater than y if the base is greater than 1, and x will be less than y if the base is between 0 and 1. The concept that we have already discussed in the last slide. Moving on to logarithms. A logarithmic function is actually the inverse of an exponential function. Any number n, this number n has to be greater than 0. So what does that mean? Log of a negative number is not defined. Even log of 0 you cannot find out. Log can be only found out for a positive number. Logarithm can be only found out for a positive number. If a number is expressed in the form a raised to power x, this base has to be what? Greater than 0, and this base cannot be equal to 1. Then the index or the power of this base is called the logarithm of the number n to the base a. I mean to say, if a raised to power x is equal to n, then this value x is the log of this number n to the base a. So log of the number n to the base a is the value of the index that we get, and a has to be a positive number and not equal to 1. So the 2 or 3 main things that I will note about n. First of all, log can only be found out for a positive number. If I talk about a as the base has to be positive. Base cannot be equal to 1. So log can only be found out of a positive number, base has to be positive, and base cannot be equal to 1. Let's take an example. If I find out log of 100 to the base 10, the value comes out to be 2. Now what does that mean? 10 square is equal to 100. 10 raised to power 2 will be equal to what? 100. N is equal to a raised to power x. So if I write 2 cube is 8, that means log of 8 to the base 2 will come out to be this. So if I write in general, log of a number to the base is x, that means a raised to power x will be actually equal to n. A raised to power x will be equal to n. The answer for log is the power for which the base must be raised to get to the value of the number. Again, for a logarithmic function, the value of the, the graph would depend upon the value of the base. So if the value of the base is between 0 and 1, it will be a different category of graph that I will get, and if a is greater than 1, the graph would be different. So let's look at the graph that you have. So in case a lies between 0 and 1, the graph of a logarithmic function is a graph that looks like this, and if it is greater than 1, it will be a graph that looks like this. So it is log of n to the base a is equal to x. So the graph would be an increasing graph. In case your base is greater than 1, it will be a decreasing graph in case your base is between 0 and 1. Let's look at some of the properties of logarithmic functions. Log of x into y. So if two numbers which are given to you in product, you can split up as log of x plus log of y. Log of x divided by y. So these numbers are in division. They can be written as log of x minus log of y. Log of x raised to power k to the base a. Now whenever you have an index in the numerator, to the number, this can always be brought outside the log sign, and your answer will be k times log of x to the base a. If this index is for the base, log of x to the base a raised to power k. This index again can be brought outside the log sign. Now the index of the base would be written in the denominator. 1 by k into log of x to the base a. If both index and the number, if both base and the number have the same index, they will cancel out and it will actually be equal to log of x to the base a. If they have a different index, the index for the number would be written in the numerator, while the index for the base would be written in the denominator. So it will be m by k log of x to the base a. Let's look at some of the other properties of log. Log of 1 to any base is always 0. If you look at it, if I just look at it, a raised to power 0 is 1. So a number raised to power 0 is 1. So if I just look at it, log of 1 to the base a would come out to be 0. Very, very important. Log of a number to the same base is 1. So a raised to power 1 is equal to a. Now if I interchange the base and the number, the log values become reciprocal of each other. So log of x to the base a and log of a to the base x would actually be reciprocal of each other. So if I just write it as log of x to the base a into log of a to the base x would actually multiply to give me a value of 1. Now this is the set of base changing formula that I have. So the first is I make the number as the base and the base as the number. The other set is if I do not like the base and I want a new base. Let me call the new base to be e. So I'll find out the log of a number to the new base divided by log of original base to the new base. So I can introduce a new base by using this formula. Now log of a number raised to power x to the base a. If you have something left like this, x can be brought out. It will be log of a to the base a, which will be actually equal to 1. This also employs a raised to power log of x to the base a. Now this base a should be here. A raised to power log of x to the base a would actually be equal to x. This is a very important rule that is there. If log of x to the base a is greater than log of y to the base a, and if I have to find out the relationship between x and y, it will depend upon what is the nature of the base. If your base is greater than 1, x would be greater than y. If your base is between 0 and 1, x would be less than y. So let's take an example. Log of 100 to the base 10 and log of 10 to the base 10. This will be greater because this answer will be 2. This answer would be 1. So this would be greater than this if your value of base is greater than 1. And in case it is not, it will be a other way out. Whenever the base is not mentioned, we'll consider it to be 10. So if there's no base which is mentioned, I'll take 10 as the default base. Now there are certain names associated with all the properties of the log. If you want, you can remember the names, otherwise it works without this as well. So this is known as the product rule. This is known as the quotient rule. All of these are power rules because they are associated with powers. Power rules. This is identity rule. These are base changing formulas, and these are again power rules that you have. Now there are certain important things that you need to keep in your mind while you are solving the questions on logarithms. So if a function is of a type y is equal to g greatest integer function log of fx to the base a, then it is known as a logarithmic function. If the logarithmic equation can be put into the form log of a number to the base is equal to log of a number to the same base, then if the bases are same, that means these two numbers will turn out to be the same. Then the solution of the equation will be the same as the solution of the equation fx is equal to gx. If in a logarithmic equation, you can write log of x to the base a raised to power k plus log of x to the base a raised to power d equals to p. Then, and you need to find the solutions to this. Then what you need to do is, if you look at this, you replace this with y. Turn it into a quadratic or cubic. Find the value of y and again put back the value to find the answer of x. If the bases of logarithmic functions are also the functions of x, the solution must make the value of the bases greater than 0 but not equal to 1. When I am solving a question on log, I will have to check the values for the bases as well. For the values of output variable or input variable that I have, the base would never turn out to be equal to 0 or the base should never turn out to be equal to 1 and should always turn out to be greater than 0. The most common mistake that people make while solving the questions of log are log of x plus y, they write it as log x plus log y. No, it is log of x into y. However, if it is log x and log y, then you can always move back. But you cannot split this thing up. And log of x plus log of x plus y is not equal to log of x into log of y. So this thing cannot be combined. Again, when you have log of x into log of y, you cannot combine back and say that is equal to log of x plus y. The only thing that can be applied is log of x into y is equal to log of x plus log of y. You cannot open up the thing and you cannot say they are equal. So these are the very common mistakes that people commit while solving the questions on log. Let's look at some of the questions related to log. If log 2 is equal to 0.3010 and log 3 is equal to 0.4771, then the value of log 16 is. Now, an important thing to consider here is the base has to be taken as 10 because there is no base which is mentioned. So what I'll do, I'll try to write log of 216 in an easier format. Now this can be written as log. I'll just do a prime factorization of this. This is 2 cube into 3 cube. So I'll write it as log of 2 cube into 3 cube. So it can be written as log of 2 cube plus log of 3 cube. Log of a into b is log of a plus log of b. Now I can bring this out of the log sign. Power rule, if you remember, 3 log 2 plus 3 log 3. Now I can take 3 common and write it as log 2 plus log 3. So this is 3.3010 plus 0.4771 into 3 would give me my answer for the value of log 16. I hope you're okay with the question. You can still look at the question once again to get to the value for this. So you can solve the value for the answer, which should come out to be 2.33. So the value of log 216 is 2.33. Let's look at another question. Now the question is same. The only thing that I've done is I've changed the base. The original base is 10 and the new base is 100. So log of 216 to the base 100 will be equal to log of 216 to the base 10 over log of original base to the new base. What is the value of log 216 to the base 10? We have just solved it out. You can move back and you can look at the sheet, which is 2.33. So if I just look at it, this value is 2.33. What is log of 100 to the base 10? It is 2. So if I just divide 2.33 with 2, that means half the value of the original will be the value for log 216 to the base 100. So this value comes out to be 1.165. Let's look at another question related to logarithms. If log of a over b plus log of b over a is equal to log of a plus b, then find the relationship between a and b. So log of a over b, it's a quotient rule. Log of a minus log of b plus log of b minus log of a is equal to log of a plus b. Now if you look here, log a gets cancelled out, log b gets cancelled out. So what I get, log of a plus b is equal to 0. Log of a number to any base is 0. What is that number? 1. Log of 1 to any base is 0. That implies a plus b should be equal to 1. The relationship should be that they would sum up to the value of 1. Thank you so much. I hope you have understood the concept of logarithms. For questions, you can move to our website edusathi.com and practice more questions on logarithms. Thank you. Have a good day.